Hello everyone, welcome to week 11. This week we just have one activity, 4.6, which is on regression. So at this point you've done regression for linear equations, you've done it for exponential, and now you'll do the same thing for quadratic. And this will be exactly what your project number 3 will be based off of. So in this situation we have, it's saying on a very hot day the National Weather Service issues warnings due to very high heat index. Okay, so we've got a table of values that shows for certain high temperatures. Okay, keep in mind it's only for these temperatures, where the humidity is 90%, and then it gives the corresponding heat index. Okay, so the first thing we're asked to do, just like we've done for all these other activities, is to make a scatter plot of this. So first by hand, I made our scatter plot. So again, stop the video, make your scatter plot, and then come back and check it with mine. But I have the temperature on the x-axis, heat index on the y, and just look at my, we're going to also do this on the calculator, so just kind of keep in mind what windows we used. You know, the same labels we used on our graph here by hand is the same windows that would be appropriate when we go on the calculator. So at first glance, sometimes this appears to be linear. The idea is when we go on the calculator, we could try a couple different kinds of regression and see which one fits it best. And that would really be based off the correlation coefficient. If I try a linear model, which one gets closer to a nice 1 for that correlation? So this one, right now, I'd say my graph looks kind of linear. I think we'll find when we go on the calculator, we graph it a little bit better. It looks a little bit more quadratic. So this number 2 is actually showing you the graph right here. If you did a scatter plot on your calculator, so do that. Put them in L1, L2, or any two list really, and get a good sketch. And I think you'll see that a quadratic regression is going to fit this better. So I have the steps over here, just like you did before. If you go to Stat, and then Calc, and then Quadratic Regression, and put your lists in, and we're going to end up getting the regression line. Okay, I'm going to call it H, or H of t, for the heat index. My regression comes out to be 0.09524 t squared minus 12.5924 t plus, I have to put that down here, sorry about that, 483.85714. Okay, so you see some parts of this are probably not applicable. That y-intercept is that last value right there is not going to be appropriate for this. So this is really only good for these certain temperatures that the National Weather Service issues a warning. So how does this plot of the quadratic regression compare? So if you put that equation in and plot it at the same time as your scatter plot, you'll see that the graph matches very well. So when you did this, your R value should come out relatively close to 1. Okay, maybe not exactly, but at least a 0.99, because you can see how well that fits the graph. Do you believe the quadratic regression model is a good fit? Yes, it's definitely a good fit. R is close to 1. And the model fits the data well, because it goes through most of it. What is the practical domain of this function? So in the beginning it says that the National Weather Service only does this heat index advisory for high temperatures. So we do need high temperatures. So we would say, if you look at the set of data values, I would say that the domain is from between 80, oops, sorry about that. Trying to erase that crazy looking 8. Okay. And it's not working. Alright, we'll just go with that 8. Okay, so from 80, x could be in between, or t, okay, we'll say t. In between maybe 80 and maybe 100. Those are practical temperatures. Okay. When the humidity is 90%, that's what this whole thing is when humidity is 9%, use a quadratic regression equation to estimate the heat index for each of the following temperatures. So I have two options for each one of these. These are giving me x values or t values, but input. I could use the table. The table is a nice feature right here if I have these, if I have this regression equation already into my calculator. Use my table and find my corresponding heat index. I could also plug in each one of these for T and get my output out. But on this one, if it's 45 degrees, then my heat index is 110, 101, and 176. So those are the corresponding outputs for each of those inputs. Which, if any of these, are most reliable? Well, the most reliable one of these is going to be the one that occurs inside my data value. So part, this number 2 is the best prediction because 85 falls within my data values. So this is the only one that's interpolation. The other ones are extrapolation. And you can see that 176 is an outrageous heat index, so this model is probably not good for that one. Okay, if the relative humidity is 90%, so again, they're just saying if this is when we get this heat advisory, estimate the temperatures for which the heat index is 100, using each of the following methods. Okay, so first they want us to do using the table. Okay, so on the table we want to find when H, or I'm calling it Y because it's the output, when Y equals 100. Okay, and you'll find that that happens when the temperature is about 48 or 84. Okay, and then graphically what they want us to do is, let's say we have our graph right here. You know, we've got these points. We've got our quadratic. And then if you go and put in y equals 100 for y2 and find where it intersects, you're only going to find one because that's the only part of the graph that we are looking at. You'll get that 84. Okay, so the graphs intersect at a temperature of 84 degrees. And then the last part that we do this is what we did in the last activity, was using the quadratic formula. So then actually setting that regression equation equal to 100 and solving it. So I know this gets to be a lot with all these decimals, but if you kind of just plug away at it and solve it, and solve this for t, you'll end up finding t equals about 84 would be the positive, would be when you do the plus, and 48 would be the other one. So how do they compare? We should get the same thing. All three ways get the same result. So it's just different ways of finding the same value. Graphically, using a table, and then algebraically. Okay, so next part we want to figure out, write an equation to determine the temperature for which the heat index is equal to 100 degrees, right? For where the air temperature and heat index are equal. Okay, so we have this formula for, we have this regression equation that shows the heat index for any given temperature. That's this right here. Okay, whoops, 8, 5, 7, 1, 4. Okay, so there's that equation, and they want it to see, well, when is the heat index going to equal the temperature? And the temperature, remember, we called just T. Okay, so if we solve that, if I bring this over here, subtract this T over, and put it over here with this one, and then use my quadratic formula, Okay, we're gonna find that T would have to be about 67.7 or 75.1. Okay, those are the 2 degrees that would make it so that both the temperature and the heat index are exactly the same. Okay, so I want to jump to the next question actually, because next flip the page and look at 8B. According to the policy, will the heat index reported ever actually equal? Okay, so what we just found before was when the heat index and the temperature are going to be the same. And what we're saying, really, is this ever going to happen? Okay, according to the reported by the National Weather Service, they don't actually start reporting until 80 degrees. So both of those temperatures were before that. Okay, so those temperatures were too low, 67 and 75. That would not be where they start reporting. So this would not really actually happen. So no, both 67.7 and 75.1 are too low for, I'm just going to abbreviate this, the National Weather Service to report. Okay, so there's another example if you want to go and try and do this. They're giving you another situation where you would find the quadratic regression. Okay, so I would practice with that and make sure you're able to do the regression, and then I would look to find the project and get that done sooner than later. Even though it's not due for a while, it's going to be posted and it's based right off this activity.